So welcome to Cubex Tutorials. This is Mahesh. So in this video, we'll discuss the volatile access modifier and the strict FP access modifier we'll discuss. Okay. The first access modifier we'll discuss volatile. So what is meant by volatile is, so volatile is one of the access modifier in Java, which is applicable for variables. So you cannot apply this volatile access modifier, you cannot apply for class, or you cannot apply for method or interface. So this volatile access modifier is applicable only for what? Only for the variable we can apply. Okay, so when we'll get if you see the table, so we prepared one table, right? All the list of access modifiers and where we can apply. So we covered up to now the transient, and in this video we are discussing volatile. So if you see for all the class in a class for method, I mentioned as no. So this volatile access modifier is only applicable for the variable. Okay, so when we'll get a requirement of applying the volatile. Okay, so before that, first let's see what is meant by volatile. Means if any variable is applied with volatile, if any variable is applied with volatile, that variable will not be maintained in cache. So that particular variable will not be maintained in the cache. So basically, when we'll get a requirement of using this volatile concept is in the multi-thread environment. So when if you are using the multiple threads in your program, so at that time we'll get a requirement of using what? The volatile. So we'll see more with an example of what is the requirement of using this volatile access modifier. So I'll try to explain with one diagram. So we have a different memory units. Okay, so one is the main memory. Assume that it is a main memory. So the instance variables will be stored in the main memory. So you know what is meant by instance variable. The variable which created inside the class is instance variable without any static declaration. Okay, so not inside any method or constructor or block. So that will be the instance variable, right? So the instance variable memory will be allocated in the main memory. Okay, so for example, I created one variable like int count is equals to, I assign some value called 10. Okay, we specified a variable int count is equals to 10. So then in my application, there are two threads are running. There are two more threads. Okay, so we can say two more threads. These threads will run on a separate process. Okay, thread 1, assume that it's a separate process, or we can say, let's say it's separate CPU. Okay, and this is thread 2. So volatile concept comes into the picture only if it is a multi-thread environment. If it is no multi-thread environment, there is no need of using the volatile. Okay, so when you are using the multiple threads, so these threads will be created in a different CPUs of the memory. Okay, so now what will happen is in the multi-thread environment, so one local variable will be created in that process, or we can say it is a cache. So for this int count, whenever you are performing some operation, like for example here, I specified int is equals to 0, for example. Count is equals to, we assign a default value called 0. So in the thread 1, what you are doing is you specified a value count is equals to, for example, 10. Okay, I updated the value, count is equals to 10 I specified. So this value directly will not update on the main memory. It will not update on the main memory, it will not update. So what will happen is it's going to create one copy, it is going to create. Okay, for the count variable, the copy is going to create, okay, within the particular process or the CPU. So one copy will be created here. like int 10 count is equals to 10. Int count. So one copy will be created in this particular CPU. So whenever you specify the statement count is equals to 10, it is going to update in this particular the CPU or cache. It will not update on the main memory. It will not update. Okay, so understand. So it will not update in the main memory. It will not update. It will update in the local cache. It will update. So what will happen is, with this approach, what will happen is, if any, for example, if thread 2 is accessing this count variable, for example, okay, thread 2 is reading the data from this count. Okay, so now what thread 2 is expecting the output what thread 1 is updated. So thread 2 is expecting the output which is updated by thread 1. But the thread 1 is not updated the value in the main memory. Thread 1 is updated the value in the cache. So this is a problems will occur in the multi-thread environment. If it is a shared object, meaning if this particular variable is accessed by the multiple threads, this is a problem will occur. If one thread update the value, how the other thread knows that? So the value is updated and fetch the updated value, not the actual value in the memory. So to overcome this problem only, so instead of creating or storing the value in the cache, so we don't want to perform the operations on the cache. We want to perform the operations directly on the main memory. For that, what we will do is we will declare the value with volatile, so that the variable will not be maintained in a cache. So the variable will be available on the main memory itself. The operations what you are performing on that variable will be done on the main memory, not on the cache. So this is what the purpose of what volatile access modifier. That's what the statement I mentioned. If any variable is applied with volatile, that variable will not be maintained in cache. So just to explain that statement, I given this diagram. So if two or more threads are accessing the shared object, then we'll get a conflict because some threads will update the value in the local, not on the main memory. So to overcome that value, if you declare the variable with volatile, so the operations will be performed directly on the main memory object, not on the cache. Okay, so this is the volatile. So programmatically also, if you want, you can see, but it's very difficult to see the output programmatically. We need two separate CPUs. Okay, but I'll write a program just to demonstrate this. I'm creating one class like a volatile test. Okay, I want to create multiple threads here. So I'm creating implements runnable. For creating a thread, we have an approach, create a class which implements runnable interface. So to create a thread, there are two approaches. Either extends the thread or implements the runnable interface. So I'm using the second approach to create this thread. Specify what is the class name, or test.java. Okay, so this runnable interface contains one method called run method. So we need to override this run method. So what is the logic you want to run in a separate process? So that logic write in the run method. So what I'm doing is just I want to get the current thread because I'm going to create multiple threads here. So which I want to get the current thread. Thread.current thread is a method which will return the current thread. Next I'm calling if t.get name is a function to get the thread name. If it is equals to first thread, okay, here I'll take one variable like I explained in the diagram. Int count is equals to, initially default I specified 0. Okay, so I'm going to call this, I'm going to execute 2 times. I'm going to execute this start the thread. So if it is thread 1, first thread for example, then what I want to do is I want to update this count value. Count is equals to, I'm specifying 10. Now if it is not a first thread, then what I want to do is I don't want to update anything, just I want to print system.out.println of count. Okay, so what we are doing is here we are going to run this one, run this thread two times. Two times we'll create a thread. Okay, two times we'll create a thread. The first thread is going to update the value. So that's what we mentioned in the diagram. The first thread is going to update the value. In the second thread, we are going to read that value. Thread 1 is going to update it, and in the thread 2, we are reading that count value we are reading. Okay. Next, I want to run this program, so we'll create a main method. Okay. So in this main method, I want to create two threads. I want to create and I want to start the threads. So before that, first what we need to do is you need to create a reference for runnable and specify what is your thread class name, volatile test. Okay. Then create a thread t1 new thread, pass this runnable object as an input for this thread. Then t1 dot start. But send the name also. So we have a method called setName method to set the thread name, giving the name as first. Then start the thread t1 dot start. Okay. Then I'm creating another thread. I'm creating another thread t2 dot start, and here we put the name as second. So now here we created two threads we created, and obviously whenever you run this program, the main is going to create a separate thread called main thread. From the main thread, we created two more threads we created. So in the thread 1, whenever you call thread dot start, the run method will be triggered, and we return the logic here. If it is equals to first, we are updating the count value. If it is from the second thread, we are reading that value we are reading. Let's save it. Let's compile and run this. Java C all test.java Java all test. So you got the output count is 10. Okay. So basically here we don't have multiple CPUs. That's what I told you in the beginning of the class also. It's difficult to see the output because we don't have multiple CPUs here. We have a single machine we are executing. But actually this is not the output you will get. If you are performing on multiple CPUs, what will happen is you will get count as 0. In the second thread, it is going to return thread 1 is updated the value, but that value will be updated in the local, not on the main memory. So to make it update on the main memory, what we need to do is you need to declare this variable with a volatile. So what will happen is the variable will not be maintained in the cache. The operations will be performed on the main memory. Okay. So theoretically understand the concept, because to see practically to see an output, it's difficult in the single machine, and to set up the environment to demonstrate this. Okay. So hope you understand theoretically what is the purpose of using what volatile, and this volatile I told you in the beginning, which is required only if you are using the multi-thread concept. If you are not using the multi-thread concept, there is no need of using the volatile concept. Okay, so this is a volatile, and the last access modifier is strictfp. So what is the purpose of strictfp access modifier is? Okay, let's see first. Strictfp access modifier is applicable for class, method, and interface. The strictfp access modifier is applicable for class, method, and interface. So this is not applicable for the variables and the constructor. It's not applicable. Okay. So we see where we can apply the strictfp. That's what I mentioned in the table also. Strictfp. So it's applicable for class, inner class, method, and the interface. It's not applicable for variable and constructor and interface. What is the purpose of using the strictfp access modifier? So whenever you are performing some operations on the floating point values, okay, these floating point values will vary from platform to platform. Okay, so when you are working on the floating point values, the output of that floating point values output maybe will be different from platform to platform. This is not sure. Maybe it will be different from platform to platform. So to make sure in all the platforms to get the same output or the same value, then we use this strictfp access modifier. So the floating point values in Java, vary from platform to platform, from Windows to Mac and Mac to different Linux, or again in the platforms we have different 32-bit, 64-bit like that, right? So this values will be vary from platform to platform. The floating point values in Java vary from platform to platform. To get the same floating point values, to get the same output in all the platforms, so we use strictfp access modifier. So which the strictfp access modifier is applicable for what? For method we can apply, and for class we can apply, and we can apply for interface also we can apply. So if any class is applied with strictfp access modifier, the methods in that class also will be automatically applied with the strictfp access modifier. Okay, this one also just a theoretical concept, because practically if you want to see an output, we need two different platforms. Okay, so and we need to check what is output we are getting in this platform and what is output we are getting in another platform. We need to compare. So it's practically it's very difficult to show in the classroom. So it's also a theoretical concept. Okay, what is the purpose is in Java we'll get the floating point values output will be different from platform to platform. To make it consistent, so we are going to use the strictfp access modifier, which is applicable for class, methods and interface. If you remember this, that will be sufficient. Okay, so let's see here. We created in this volatile test, right? So what I'm going to do is I'll make this class as a strictfp class volatile test. But before that, first what we will do is let's see Java p volatile test. Just so I'm seeing the information of this existing class. See, this class volatile test is a thread which implements runnable interface. We have a public void run method, public static void main method. So these two methods, right? Now let's save this. Let's compile. Java p volatile test. So now you can see the run method and the main method. But the run method and main method, we have not applied the strictfp access modifier. But how we got the run method and the main method we got with strictfp access modifier is, I told you, so whenever the class is applied with strictfp, all its methods, if it's having any inner classes, so those will be applied with the strictfp access modifier. Okay, so hope you understand this, the strictfp access modifier and the volatile access modifier. So with this we covered all the access modifiers we covered. We covered what? All the access modifiers we covered. Okay, so thanks for watching the video. So please like the video and subscribe if you are not yet subscribed.